Have you taken a selfie and not got it right? And then say, take it from this angle. Okay, let's try from this angle. Let's try from that angle. Let's try from this angle. You must have done that, right? Did you know that you're using a concept of geometry in this? That's right. You're using the concept of geometry called the angle. Take it from this angle, take it from that angle. And when you've been watching a football game and your favorite football star just missed getting a goal, oh my god, if just he had changed the angle and hit it this way, he would have got a goal. Have you said such things? Yes, there again, you're using a concept of geometry called the angle. So, we keep using concepts of mathematics in our everyday life, always. So, mathematics is not just a subject, it's a life skill. In this life skill, it is very important to drive away some of the misunderstandings that we may have. Otherwise, we may not be able to utilize mathematics in a right way in our everyday life. Today, in this video, let's talk about some misunderstandings about angles that we have so that we can use those concepts in our life.
Now, let's understand some misunderstandings about angle. When a student is presented with this figure and asked to mark an angle, what does the student do? They mark an angle like this. But this is not the angle, right? To understand what is the angle, we will first understand how an angle is formed. We know that angle is formed using two rays. Okay, so let me start by taking one ray. Okay, let us name this ray as OA. OA is one more ray. We know an angle is formed when we have one more ray starting from the same O. Okay, starting from the same O. Let me take a one more ray starting from AO. Now, you see this ray could have been here. Okay, see the common vertex, common thing is starting point is O, and we can move this anywhere. So now when I'm keeping this also, here also an angle is there, here also an angle is there, here also an angle is there, and here also an angle is there. Then what is it? What is it that is changing? Is it the length of OA or length of OB? Let's say this is the name of, let's name is that B. Is it changing? This one? No. What is changing? What is changing is this part. This part, the space, what you can call, between the OA and OB, that is what is changing. So when we have to mark an angle, we have to mark it this way. Okay, it is not the arms. Now let's understand the terminologies. O is called as the vertex. O is called as the vertex. And OA and OB, these are called as the arms. Fine. These are called as the arms. There are two arms for a angle. Okay, two arms for an angle. So OA is one arm, OB is one more arm, and O is called as the vertex. And this is the angle, the inside, the curved line is actually the angle. It is not OA, it is not OB, it is not O. Now, how do we name an angle? There's one more next misunderstanding that children have is how to name an angle. We can name an angle either for this angle, let's say, we can just say O, angle O. Or you can also write it as angle O, like this. Or what is one more way to do? One more way is to use both the arms of the angle. What is the arm of the angle? OB, OA. So using the arms, I have to write BOA. If you notice, the vertex should come in the middle. You can also write it as BOA with the angle sign on the top. This is also the right way. Is writing AOB meaning the same angle? Yes, it also means the same angle. Why? Again, we know O is the vertex. Whichever is the vertex, whichever is the common starting point for the angle, that is in the center, and other two arms. Say for example, AO is one arm, OB is one arm. So both the arms are mentioned. Now, if I have an angle, if I have a let's say one more angle is formed in between. One more angle is formed between using another ray. Let's name this. Let's name this ray. Let's name this ray as OC. Now, can I tell just angle O? No, it will become ambiguous because at the O itself, there may various different angles formed. So when you just say angle O, it will be confusing. We are not supposed to say. In this case, we have to use the arms to mention what is the angle we are referring to. Now, for example, if we are referring to BOC, if it is BOC, then we know it is the measure between the arms OB and OC. That means it is this part. The blue color part is what we are talking about. Now, if I say AOC, if I say AOC, it will be the arms using OA and OC. This is AOC. This one is angle AOC. Using the arms OA and OC. So, at a vertex, if we have more than one angle, you cannot use just the vertex name to refer to the angle. If only one angle is there, you can say it as BOA also or just OA as an angle O also. That time there will be no problem. So first thing is that. Now let's clear the screen and now let's learn how to measure an angle using a protractor. Here also many children have confusions. So we know angle is formed using two rays, okay, and also, okay, an angle is formed using two rays. Now, next misunderstanding is, now if I increase this, does the angle become bigger or more? No, it doesn't become bigger. If I make it like this, does the angle become lesser? No, it doesn't become lesser. I'll show you with two examples. Let's I take a ray here at this position. Next, I take one more ray of the same length. If you see this top blue line and the second red line are of same length approximately. Now let's see whether the blue line with the bottom blue line is giving you a smaller angle or a larger angle. Or okay, let's take even this. Okay, let's make this A as larger. Or let's make it, let's say, smaller. Okay, length is smaller. So we will measure both the angles using a protractor and understand which one is smaller. Is it the red line formed angle which is smaller, or is the blue line which is formed the smaller angle? We'll learn that. For that, first we have to understand how to measure an angle using a protractor. There are 3 points to be kept in mind. First point, the center of the protractor, okay, center of the protractor is on the vertex. That's the first point you have to check. The second point is one arm of the angle on the zero line. one arm of the angle on the zero line of the protractor. Next, third thing, the angle, right? The curved line that you marked, that angle is inside the protractor. If you take care of these three things, then your measurement of angles will be proper. Okay, now let's take a protractor. Let's take a protractor and try to understand this. The first point is center of the protractor is on the vertex. Now this is the center of the sun, right? This is the center of the sun. Now to take it and keep it on the vertex. This is our vertex, the common starting point of both the rays of an angle. Now, next point. Now we are going to measure the blue color angle. So one arm, second point is one arm of the angle is on the zero line. So is it on the zero line? Do you see the zero here? Okay. Do you see the zero here? This zero is not on it properly, right? So now it is on proper, zero is on one of the arms. One arm of the angle on the zero line. Now, there is a 0 also, there is a 180 also. We must take the 0 and we must go in the bottom, the below part counting only, we have to continue. So with the 0, when I am trying to measure the blue color, I have to go to till the next arm. 0, 10, 20 and say this is 23. 23, between 23 and 24. Okay, between 23 and 24. Let's write it. Let's keep it as, let's approximate it to 24 degree. Okay, this is 24 degree. Now let's see how to measure the red color angle. The red color angle is formed with the red color line and the bottom blue color line. Those are the two rays which is forming that angle. Now again, center of the protractor on the vertex. Center of the protractor on the vertex. One arm of the angle is on the zero line. What I'm measuring, angle inside the protractor. We understood. So, okay, let us mark it. Let us mark the angle. The marking the angle, as I told you, we are not supposed to mark like this. That's not the right way. Marking of the red angle is to be done like this. This is the way to mark the red angle. So now I'm keeping the thing on the vertex, the center of the protractor on the vertex, zero line of the protractor is on the one of the arms. Now I go to the other arm and the angle that we are going to measure is inside the protractor. 3 points also taken care and the 0 is here. So we go here 1, 0, 10, 20, 30, 40, 50 and this is coming somewhere near 55. If you see, it's between 50 and 60. So the angle is 55 degree. Now, did you understand? The red ray is shorter in length, but the angle it forms with the bottom blue line is 55 degree. 55 degree is greater. Now, the blue line, the other blue line is longer than the red line, yet the angle it is forming with the bottom line is just 24 degree. So, I hope you understood that it is not the length of the arm that decides whether the angle is more. It is how much it has turned. Right? I hope you understood. All your misunderstandings are gone. And you also understood how to measure an angle properly using a protractor. Please remember these 3 points, then you will never go wrong in measuring the angles.
There's one more challenge that children face with regards to the concept of angle. When they have to talk about what is an acute angle, obtuse angle, straight angle, right angle, compared to all these things, they get a lot of confused about what is the acute angle and what is the obtuse angle. I'm going to give you a simple hack. A for acute angle, O for obtuse angle. A comes as starting and that means it is the smallest. It is smaller. Okay, so it is whichever angle is smaller than 90, we call it as starting from A, acute angle. And the other one which is greater than 90 should be a obtuse angle, right? I hope this will help you remember the names of the angles which is lesser than 90, which is acute, which is greater than 90, which is obtuse, and exactly equal to 90 is called a right angle, and whichever is equal to 180 degree, it's called as a straight angle, correct? So I hope this removes all the misunderstandings about angles and also shows you how angles are used in our everyday life. Thank you. Bye-bye.